Good morning, good afternoon, everyone. Welcome to today's webinar. My name is Mikhail. I will be your presenter. So in today's webinar, we will talk about using Python to process data as if it was some sort of SQL engine. We'll talk about using it on the platform that is known as Spark. I would expect that many of you are familiar with the system. For those who are not, I will do a quick introduction into what Spark is. It will be 2 or 3 slides. And the majority of the presentation will be dedicated to discussing SparkSQL or DataFrame API. So we feel that there is a big demand from business community, from business analysts, from people who are data practitioners who would like to use something fast, intuitive, resembles SQL, and which would enable you to process data on a large scale. So today's presentation will be recorded and it will be published later on. So if you would like to download it, you can do it later. So it looks like we've got quorum. So this presentation is targeting the not kind of a programmers. Even though you can have a programming background, you can be a data engineer, you can be software engineer, but I guess the primary focus is on how to make Spark, or more specifically PySpark, Python on Spark, to work for you as a kind of a SQL-like interface. And that would be the main, I guess, topic. There will be some discussions around some other points. And it looks like what's happening, what we see in the field is that people exploring and going into the area of processing big data on a cluster of machines using a variety of systems. Like Hadoop gives you Apache Hive or Impala, similar systems that you can find. But at the same time, you can just observe that more and more people are using Spark. It plays very nicely. It's very nicely integrated into the Hadoop product ecosystem. It works against HDFS. It works against other types of storage. So if you have any questions as we go, you're not able, I won't be able to enable your voice questions, but if you would like to put your question in the chat window, feel free. So the tools, the toolbox includes Apache Spark and Python. So those are the 2 things that you need to be familiar with in order to take advantage of that SQL-like capability that is available to you on this platform. Apache Spark is an open source project, as you can judge by the Apache in the name. You can download standalone Spark, but you are better off to use Cloudera distribution of Hadoop, or CDH, which comes with all the Hadoop products, the main products used on Hadoop, including Spark. Unfortunately, Spark might be a little bit dated, not maybe the latest 2.4, even version 3 now, but it's very well integrated. It can read the Hive meta store. You can get very nice integration with HDFS. Also, for experimentation, you can use Databricks Cloud. There is community edition, a little bit scaled down, not enterprise grade really. There are some limitations as to the number of CPUs, virtual CPUs. which will be allocated, and the amount of memory, the size of data sets that you can provide. Databricks by the way, Databricks is a company which was formed by the original developers of Spark, so they know the material. Databricks Cloud is based on Amazon Web Services. And the focus in today's presentation will be Python, even though you can use Scala, you can use Java. Some people even use R, but R is more limited to standalone and Databricks Cloud. It's not very well integrated with CDH. So quickly, what is Spark? I don't want to preach to the converted. If you know what it is, just bear with me for a couple of slides. So Spark allows you to process a massive amount of data, which is stored on a cluster of computers. So essentially, it's kind of a Hadoop, but much faster. If you compare Spark with the MapReduce engine, it's several orders of magnitude, 2 or 3 faster. It's just almost near real time. You can interface with Spark as a platform using your expertise in the languages listed here. So the consensus now is to use Scala for mission critical applications where you really want to get squeeze every ounce of performance. Java probably just losing to Scala in terms of the concise syntax and very compact API. For data science, machine learning, even though those are not the topics, we've already published a number of webinars on this topic, machine learning, data science, data engineering with using Spark. And here we are just looking at, again, at the SparkSQL module, which gives you access to SQL-like interface to the underlying distributed data. So the main advantage of Spark is that it tries also to lure people from the business side of the organizations to use SQL queries, which can be embedded. So Spark platform, it's versatile, quite rich in terms of functionality. You can have, you can find libraries for solving your machine learning tasks, processing graphs, and near real-time processing using Spark streaming. But the focus of this presentation is SparkSQL. What's interesting about the platform is that all those modules, they are integrated across the Apache Spark platform, meaning that you can ingest data through the Spark streaming endpoint, which is sort of like socket server. Data is streaming in, captured in real time, and then you can apply machine learning algorithms on the fly. Right, SparkSQL is no different, but you are better off to process data in batch mode, so that you have ingested data. Data is sitting on your cluster at rest, and you would like to process it to get some insights. So Python. So I mentioned earlier that the tools of what most people have started using, and that's where I guess people are coming together to use Python. Python is a very popular language now. You can find it in various parts of the IT landscape. You can use standalone Python and standalone Python running on your laptops. You can use scikit-learn for machine learning. Python and Spark is a regular Python, which has been augmented with libraries and interfaces through the Spark platform. It's called PySpark, Python on Spark. Python is also nicely integrated with modern integrated development environments, which including Jupyter, and it has very nice production-ready visualization supports, such libraries as matplotlib and seaborn based on matplotlib give you very nice and free visualization capability. So PySpark, it's a little bit noisy slide, but it just gives you a little bit of a background so that you understand it's regular Python. It has been implemented using CPython implementation. When it runs on a cluster of machines, particularly on Hadoop, it uses JVM, so Java Virtual Machine needs to be present. And there is the RPC library, which sits between Python and Java. So you might say that it's kind of be very restricting, but in fact, Python is pretty much a kind of a dispatcher. It just sends the requests to Java, and Java actually performs all the heavy lifting. And Python just provides wrappers around the objects returned through that RPC, remote procedure call bridge. Okay, so you are not losing very much, other than that Python itself probably is not as performant as you would expect from other languages. Like Java and Scala is definitely a better choice if you really have mission critical applications or applications where every second or minute of processing time counts. Python would be a little bit lagging behind. And probably it would be the last, a couple more slides about the Spark. So is that you understand that things are being processed on Spark in a distributed manner. You've got your data sitting on 128 machines and belonging to a particular logical file. It's just been partitioned as if it was file allocation table. And you will be able to process the data on all those machines. So there is this distributed processing model, like scheduling of tasks to run on a cluster of machines working on that piece of the data, that split of the data, segment of the data. So there are some concepts that you should be familiar, like the executor, the driver. So driver essentially, it's the entry point to a program. It's a public static void main, if you're familiar with Java or Scala. It's the main entry point, and you create Spark context, which is an object interfacing you with the rest of the system. And then you will be going through the cluster manager of sorts, be it Spark standalone, Yarn, which is Hadoop, or Mesos. And the executor is a JVM plus Python runtime, which work together in that RPC bridge. Spark tries to solve all the tasks in memory without really discussing executor processes. It tries to reuse as much as possible, aggressively using caches. So those tasks can be anything. It can be a specific task for selecting data or filtering. It can be map reduce as well. So if you say you've got 3 parts of your data sets sitting on 3 machines, so there will be 3 executor processes allocated by the cluster manager, and the driver program would actually be driving through the application manager to make sure that every block of your data is processed in sequence. And the output, pretty much you've got 3 threads of execution. Okay, so that's pretty much it to set the background. So now we understand that Spark gives you all the mechanics that's necessary. So now what about the API? In order to take advantage of the SQL, the embedded mode, and more, you should use SparkSQL. So everything is already integrated. You don't need to do anything extra other than just initializing the interface to the SparkSQL module. What's interesting is that SparkSQL, even though it sounds a little bit limiting, that SQL probably is not enough. So I can get SQL from Oracle, DB2, or Postgres database. But the thing is, first, processing will be done in distributed manner. Again, thousands of computers, hundreds, tens of computers can be involved, enlisted in processing your task. That's one thing. The other thing is that SparkSQL offers you uniform programming API to work with a variety of data stored in distributed manner. So your data can be in any of those familiar to you standards like CSV, JSON. But in addition to that, it also supports Avro, which is very popular on Hadoop. It's kind of a serialization format, and columnar stores, Parquet and ORC, which are a very efficient mechanism for storing data and for data retrieval. You can also connect to available JDBC database, JDBC enabled, and there is a JDBC driver which would allow you to pull the data out of a specific database, bring it into Spark, process the data in distributed manner. Probably it will be a little bit of overkill. It's not a very popular thing, but still you can quickly prototype certain tasks and probably compare some time. If you run a similar query on the target database and then you download the data source, you pull all the data from a particular data and you start processing it using Spark. Of course, you don't have the ability to take advantage of indexing, clustered indexes, and whatever is available on the database side, but there is no, I guess, limits as to how many machines could be involved. So that's, I guess, the context. That's the big picture where things are. And now let's go right into what SparkSQL is about. SparkSQL is based on the DataFrame. It's the fundamental storage in-memory storage construct. It's an object which allows you to wrap up in a logical way distributed collection of data. Distributed means across cluster of machines, and all the coordination of the processing, dealing with failed nodes, restarting, potentially doing some optimizations to circumvent certain steps, is done at this level. So data frames, if you're familiar with R, that's where, I guess, they got that name, pandas. Essentially, it's very close to a table, the concept of a table in a relational table database. DataFrame API, it's just new generation structure or API, which is based on the low-level RDD type of API. So RDD, there were some iterations with RDD getting the data set, kind of a facelift, but data set is type specific. It's a strongly typed system, and only Scala and Java can take advantage of it. And DataFrame, essentially, it just creates a uniform wrapper, which would allow Python to tap into that underlying dataset API, right? Also, DataFrame, in addition to exposing SQL-like API, gives you access to transformations based on functional programming. We are not discussing it. Again, we did a couple of presentations, 2 or maybe more, on using functional programming to extract data using MapReduce, flat map, filter, and a variety of others, using pair RDD and very esoteric topics which we're not talking about here, but they're there, meaning if you have exhausted all your venues to extract data in the most efficient way, you can always fall back. There is a backdoor for in the data frame to get to access. It's not actually a backdoor. It shouldn't be like that. I don't want to deprecate RDD. It's still there. It's just a matter of getting that last resort, kind of plan B, to use. And it gives you a way to expand your, I guess, your tool set. So data frames, normally you construct it when you load the data from any of the supported data sources. You can construct it from data sitting in memory of those machines. Spark RDDs is another source. You can read meta store of Apache Hive if you run Spark alongside with Hive on Hadoop and JDBC sources. So you get the data from a database and you wrap it up in a data frame. Essentially, you get yourself a very nice data frame. So the question would be, so what? Probably it's time. I'm not interested. It looks like it's just another kind of technology I have to learn. But what's happening is the dynamic is now that people are trying to experiment and probably save some bucks on licensing. And Spark gives you a very viable, sustainable alternative to existing products in that space. Of course, nobody is going to replace all those major databases that are currently used in production. They have their own set of use cases, and they cannot be beat, be it online transactional processing or very efficient querying. But at the same time, I guess that's a new wave of technologies that is here. It's not hype. It's not. We are not going to sell it. We're nowhere associated with Databricks or any other company, AWS. We just want to enable you to give you the right tool for the right job. So as Marshall McLuhan said, and I used his quote, we pretty much live in the age of anxiety. So we go to kind of a bronze age, and we're slowly progressing, and now it's the age of anxiety because we are not using the right tools for today's jobs. We are still thinking in terms of old categories, old concepts and ideas, using old tools. So uniform API. So I mentioned that. I'm going to reiterate it because that's what really done well in Spark. You can also join data. So you pull out data from a JDBC database, and you can join with data frame built from, say, in memory. So you can perform probably a very good fraud analysis system. So you get the data in real time, you do the batching, you extract the data, and you run this batch across, I don't know, a particular time horizon. You get the insights, and it can be done in almost near real time. So here's a couple of examples. It's more of kind of a technical presentation, but at the same time, I would expect that you would see what is behind it, right? So all those kind of syntax things, all the statements, they just tell you the story that pretty much when you execute this line, we're using PySpark, Python on Spark. It gives you a way to load the data in a specific format. There are also methods for ORC, the machine learning libsvm format, Parquet, and what's not. There are two types of syntax. You can find one as that read class exposes a bunch of methods which are specific for any of the supported file formats. You can also use another method called format, which takes the type as a literal. And you load the file from any of the supported storage types. And usually people use HDFS because that's where Spark plays really very nice, right? And that's it. And on the left, you've got DataFrame. This is Python. If you're not familiar with Python, I'll just quickly kind of give you a sense of what it does. So DataFrame is not qualified. It's not defined in any way as a data frame using any of the statically typed language. Things would be identified at runtime. So the statement on the right-hand side would generate an object, and Python would identify it as being of type DataFrame. And then DataFrame would give you the API, which we're going to take a look in a moment. So we are just continuing with ways to create DataFrame, right? So you can create a DataFrame from data in memory. Spark is a Spark context. It's a session object, pretty much just gives you access to a plethora of kind of wide range of methods and properties, attributes that allow you to manipulate data very efficiently. So what we're doing here, maybe I will just quickly annotate it. I'll use red. So we create a data frame on the left, right? And what happens here, create data frame, very nice, speaks for itself. First, we create value rows. It can be for lookup tables. You can create really data that you can fetch real time, let's say from database. We use arrays, so those square brackets indicate that we are creating an array. And Python uses the concept of tuples. So those tuples around brackets essentially allow you to create records. Those are unmutable representation of your data, which have columns, fields, right? We've got 3 fields, as we see. And in order to associate that value records with some sort of simple schema, we would assign column names. Okay, so we'll have every field from the tuple associated with a column. So pretty much you become someone who creates data frame on the fly. Also, you can have more low-level way to create the data. You would use the raw objects that you would export from the SQL module. And then you would create all those objects. And at this point in time, you have very nice schema because things would be easier because system would identify that now pretty much we've got everything associated. So on the left, we've got, it's not the optimal way, but it just shows that it's possible to do it this way. So now that's kind of was second, right, third, and there's a fourth method where you would say, what I'm doing now, I'm just showing you that first you need to create a data frame so that later on you can use it, a data frame, to use that APIs that we are going to talk about shortly, right? So usually people don't see it and they somehow get stuck, get frustrated. So someone just promised SQL, but how can I get that to that SQL? You need to do this step. You need to go through that. And I pretty much, I guess, show you how to quickly start applying your knowledge in production without delaying and putting it to kind of a forget it button bucket. So let's say you've got an RDD that you somehow generate. You might have read it from any of the other sources, let's say from HDFS. It has been probably serialized in some way. And there is a backdoor that I mentioned, 2DF. So essentially you've got yourself RDD, and it allows you to convert the records stored in raw format in RDD. RDD pretty much it's just an assembly type of thing, low level, very efficient with lineage, all the infrastructure things are there. But data frames are nicer. They are more user developer friendly. So what you do here, you just take all the fields from every row in your RDD and you assign column names. So essentially, your data frame would be the original RDD, which has been decorated with columns and some additional meta information. Again, if you have any questions, let me know. Put your questions in the chat window. So the first questions that people, maybe the second question that people start asking, how can I create a data frame which caters for some specific requirements, data requirements in the data set? And usually it comes with accurate schema, which by default, when you start creating data frames, everything is treated as an array of characters. It's just a string, right? And in many cases, it's not what people want. Of course, you can convert a string into double value or an integer, but that's not the case. How we can do it in one kind of a fell swoop? We just start doing it when we read the data from a particular source, and we would like to have very accurate schema because we know a priori or otherwise that that's what we want. So if you just read JSON or that CSV file, on the left hand you will see that everything will be string. But NT-cars, it's a small data set which is very popular with R folks, and just shows you that a little bit of domain-specific object. Everyone understands in one way or another about cars, about engines, number of cylinders, miles per gallon. displacement of engine, horsepower, and things like that, right? So if you specify the options that you would like to infer schema, what Python, or more specifically the infrastructure of the SparkSQL module would parse the data, it will apply some heuristics and it will derive that understanding that it would be better off to use miles per gallon as double, right? It's just because there would be a decimal point in that column. Cylinders, it's an integer number, it's a whole number, no decimal points should be used. As you see, our system is quite intelligent in getting those insights, and you get yourself a nicely organized schema so that you can have a better performance and nicer API, right? Also, you can specify schema on the fly when you read the data. You just create that string, which has kind of two value elements, card name and string. Essentially, it's a string, but it's just it's kind of a key value pair. It's a very nice way. What's good about Python is they don't really think that they would look kind of stupid when they do things like as simple as that. More enterprise-minded people, folks like from Java, they would probably create an XML with C data, maybe with schema or something else. So the schema would define the schema in DataFrame, and it can go on and on. I worked in enterprise space for quite a long time. I'm a certified enterprise Java architect, and I know how to make it look very formidable, very serious, so that you can kind of puff your cheeks and just go as if it's just you solved the world hunger problem. But Python is much more, I would say, it's much more agile. That's what I guess most appropriate adjective that you can use in this context. And then header is true, speaks for itself, right? So now, you've been talking about the SparkSQL. So now, where is it? And that's what it is. Essentially, first thing that you need to do, let's say you created data frame in one way or another, and then you can do the following things. You need to register it as a temporary table. So Spark or SparkSQL will create that infrastructure for you to start converting that embedded SQL that we talked about. SQL is a method of the Spark session. It's kind of a Spark context object, which exposes SQL, but you can only run this SQL against something that is known as a temporary table. So let me just quickly walk you through. So first we created a data frame, right? We registered. So this is a sort of a logical name, which would be used by some optimization mechanisms used like Catalyst. And then we use SQL methods to issue embedded SQL against the table. That's it. Show means just brings data and display it in the driver process. So you can have quite elaborate SQL. You can do grouping, you can do filtering, you can do some regular expressions, you can do counting, averaging, and having is also supported. So that's pretty much what you can do. It's at this point in time, you can say, so where's advanced? It's advanced because you now are able to run this query against potentially hundreds of machines. So that's where advancements comes. It's not coming from select. There will be a couple of points later on, but that's the point. So you use pretty much SQL, which runs in a distributed manner. Those people who come from Apache Hive background, they would say, we can do it in Apache Hive way. And they will be right, but in order to take advantage of more optimized, by default, Hive runs on the MapReduce engine. Of course, you can switch to Apache Tez, or you can use, by the way, Apache Spark engine, but it would require some experimentation and setting, doing the things right. Here you've got SQL just embedded, right? Don't forget to drop it, because again, when you start experimenting, many people would get frustrated because at a certain point in time, you'll start getting out of memory exceptions and other ugly kind of manifestations of the fact that you haven't done good kind of thinking. You haven't cleaned your memory from those objects. Wouldn't be discarded automatically. They would be sitting there consuming potentially a lot of space. In terms of presentation, I believe you should have received a link to that PDF file. I don't think that I would be able to do it right now. Let me send an email to our back office people. Just give me a second. Yeah, I don't see that I would be able to share that with you. Just give me a second. Just one more minute, guys. Yeah, almost there. Okay, guys, sorry for this delay. I guess, yeah, I haven't been able to share. Usually when you use other tools, you would probably be able to see much richer API where you would be able to upload files so that people can download. But I've got the slides. I don't have any problem. It's in public domain. So let's continue. So that's SQL, right? It's just nice, well-rounded, and you know SQL, right? As long as you know the field names. How would you know the field names? So there's a way for you to dump the schema of data frame, like def print schema, or essentially you define schema here. So that would be the column names, and column names would be used in that SQL that you run here. Okay, so it looks like we're good here. So now what, right? So in addition to SQL, that you would be probably very close, dear and near to many of business analysts, you can also kind of emulate SQL by using yeah, it looks like, yeah, sorry, I was looking at the chat, but it looks like some people are using the questions and answers panel. Okay, good. So the question is, what's the difference between temp table and temp view? So with view, I don't know exactly because I only use temp table. A temp table would allow you to modify the data, right? Temp view would probably allow you to only use data for reading, right? If that is supported. I haven't explored that, that capability. And another question is, do you know how Spark handles count distinct with group by? It's not easily parallelizable. In general, as intermediate results from each node needs to be collected in one. For the final number of unique values. when you perform distinct, distinct essentially can be run. You can pretty much break your count distinct group by into multiple staged scripts, right? So you can help Spark a little bit at this point. So you would probably perform like finding distinct values first, and then you would apply group by against that. So it's possible in some cases, but you're right. In terms of parallelizing queries on cluster machines, it's not always possible because things would be shuffling, sending across. And one kind of a big item, big ticket item solution is to use lookup tables, which are broadcast variables. So what you can do, you essentially can have probably some pre-built maybe artifacts that would allow you to simplify lookups. And broadcast variables, they use UDP. It's kind of a ubiquitous protocol which allows you to efficiently share the broadcast variables, kind of a lookup tables across the cluster. And then on every process, on every executed process, you would use the broadcast variable to look up and select the values, right? And it can be parallelized. And then the aggregation, kind of when you need to pull the data down back to the driver process, it would take kind of a much less, I guess, hit. It will be less painful, right? So it's a big topic, right? It's kind of a big thing, but definitely the solution would be don't try to put as much in just one query, right? So it would be suboptimal. And that's what kind of confuses people. Yes, you've got select, but even though if you have it, it doesn't mean that you have to use it in this way. Same applies with using functional programming, with MapReduce. People start using that kind of a chaining of operators using dot notation, and it goes on and on and on until people get out of memory exception, right? And it just starts really frustrating people. So don't just try to avoid things. Just try to partition it and think about in terms of kind of how to process data piecemeal. You probably would need to do reorientation of data, but having said that, it would be much more easier for you to do it using the DataFrame API or using Scala, Python, just functional programming, as opposed to just one single SQL statement, which we would use. Of course, you can use PLSQL, TSQL, other systems, which would allow you to do this partitioning, kind of piecemeal processing. But the programming API of SparkSQL just lends itself to kind of a staged processing. Hopefully it answers your question. Okay. Right. Okay, so moving on. So we've got kind of the API that allows you to emulate that projection, select projection statement. Right. So we've got a very nice way. And by the way, this slide just shows side by side the actual DataFrame SparkSQL API alongside with the select SQL statements. So that's what you can do. Now, I'm not going to read unless I see something that would require some clarification. Yeah, in some cases you can use select. Essentially just emulates the select clause projection. So you can specify the names of columns, but also what is supported is that dot notation, and Spark, like Jupyter Notebook, it would allow you to use auto-completion. So a system would cache the schema that is associated with a data frame, and you can use things like that. Okay, so filter is a where clause. So you can do distinct, so you do select and distinct days, IP addresses, credit card numbers, and do the count, right? So again, so probably back to the question of green withers, I guess you can play around with maybe DataFrame in this way. Yeah, grouping. So let's say you group days by months or something. So I guess somehow you can just start looking from this point. And time, definitely timing all the processes, how long it takes, user time, kernel time is important. So sorting data, it's similar to the sorting data in SQL. By default, it goes in ascending mode. If you want to do descending by a particular column, you need to use that method. So it's a little bit different from what you would do with SQL. Of course, if you want to use SQL, you can use it here. Here, you would be dealing with only DataFrame type of API. You can also join tables, join data frames, and data frames should have that single month field or column that would allow you to join one data frame with another. The join data frames, you can do left out, right out, join. Here's a grouping operation. So grouping would use the group by method, but you can also, if you want to find aggregates within those groups, you can use that JSON type of syntax. Aggregation is a method which takes that stanza and it does aggregation of finding the maximum value for days, which has been grouped by months. Right, so that's what an equivalent SQL statement would look like. Okay, so pivot tables are supported, and this is just a breeze. So that's what I guess what is interesting about the DataFrame API. It's absolutely easy to just create a pivot table from any values that can be kind of treated as categorical values, as some sort of enumerated types. Like for example, that empty cars, it has two factors, factor variables, cylinder and gear. So there are 3 values for each, and that's how you create a pivot table. You do the grouping, so essentially you designate the columns that would act as kind of a row, and the gear would provide the values. So there'll be 3 columns, 3, 4, 5. You perform counting of occurrences of records which would contain the intersection of cylinders and gears. So that's what would be the raw API output of that statement when you run it. Collection means that you bring the data in the driver memory, right? And if you would like to visualize it and have a nicer way to do this, that would be the way. So you specify the rows, and rows are essentially returned by this statement, and you specify the columns, like those would come from pivot, and cylinder would come from the cylinder value, and that would be a very nice aggregate value. Null means that there is no car with 8 cylinders and 4 gears for manual. So there's a question created out of main df in this example. Yes, those are kind of separate data frames which have some relation, and the relation is expressed in the months, and we just want to combine. So we potentially might get it from different sources, from different vendors, but they should have similar structure, sharing that months column. Hopefully I was able to answer. Right. That's it, more on pivot tables. So this is kind of a more of a summary report. You get the data, you combine them quickly. That is a very powerful operation, and you display it, right? It's good. And by the way, what you can do at this point in time, you can do some sort of a heat mapping. You can apply some labels, do visualization. You can build a pandas table. Unfortunately, the time for this presentation doesn't allow us to give you a better kind of a coverage of the materials that we have, such as EDA, exploratory data analysis using pandas and Seaborn. And you can say, just to give a very nice executive type of summary. Also, you can do a more elaborate. So here we use count of the cars, number of machines, which have those collection of attributes. If you would like to find some weight, is I guess it's a weight of in pounds of a car divided by 1,000. I don't remember exactly, but essentially what this operation does, it allows you to build a pivot table where instead of the count, every cell in that table, like a virtual table, which could be converted into a data frame, would collect the sum of weights of this car. And we see that by just looking at the data, we see that the cars which have 3 gears and 8 cylinders are the heaviest one. Or maybe not the heaviest, but most of the cars are in this area. So if we go to that table, yes, we've got 12 cars in this space. Pretty much we kind of collaborate data. There is some sort of correlation between the count and the weight, right? So that's what I guess was the point. Of course, there is more, and definitely it wouldn't be possible to cover everything that we talked about here so far. Usually there are more questions, right? And so that's the materials that we offer our clients. It's a 2-day class, which is, has lots of hands-on. You just be touching on theory a little bit and then spending time, and you will explore DataFrame API inside out. The lab environment is staged in Databricks cloud. You will also have exposure to this environment so that you can immediately, with no delays, by the way, it's free access. You can start experimenting with your data so that you can get output. You will get instant return on your investment of your time. So after 2 days, you will be able to start processing data, not using only SQL, but also more generically the DataFrame API. So that's all from me for today. I haven't heard from our people at the back office. Maybe there are some, we kind of experienced some problems with some of the parts of the organization being shut down due to that situation in the health department. So we still have a couple of minutes left before we end this meeting. Any questions? So the question is, what is the best way to practice PySpark for free? As I said, Databricks community cloud, right away, instant. You just need to provide your working email, and they are very proud of what they're doing. They're not going to ask you for a credit card number, for your mother's maiden name, for anything else. Just provide email, you get the feedback. They pretty much are so confident that you will be continuing to work with them, and eventually you will upgrade to a production license. So you can experiment it for free. That would be the best way I can suggest. If you kind of are more inclined to do things in a hard way, download Spark standalone and start doing things there. It will be a little bit more of a headache, really. Other questions? I'm into eLearn to practice PySpark. This class is offered for, it's not pre-recorded, right? I'm not sure what would be the best class. It depends on your background. There is no answer that fits all questions. No, I cannot answer. So I guess try, I don't know, there's so many classes out there. Plural sites, I don't know. Go there and whatever is currently, it's all over the place. But what I would like to tell you, that all those classes, they give you some sort of pre-recorded messages. Probably you'll have access to some sort of a lab environment. And when you start experiencing problems, if a lab is simple enough, you will be probably able to finish it without learning much. But if you have any problems, probably there would be some sort of forum where you can post your question, and probably someone would get around answering your question, but don't hold your breath. That's one thing. The other thing is that your support would expire sometime after the class. So you are better off to do either virtual training, like through our company, like WebH, or in-class training when things with that COVID situation stabilize and that pandemic would be reduced to, I don't know, acceptable minimums. Okay, so if there is no more questions, guys, going once, going twice. Okay, thank you very much for attending. I wish you every success, stay safe, and learn PySpark. That's my best advice. Okay, all the best, bye-bye.